Okay, from section 2.4 we have numbers 49 and 51. So in 49, I think it's a little deceptive. Usually, if what this is saying right here is that you are squaring the input of sine. When I write something like this, I'll even include extra parentheses. I'm saying that what's going into sine is being squared, right? If you saw something like sine with a 2 right next to it, with pi x, then this would mean that the output from the function sine would be squared. So only by convention, by the fact that the 2 is not here but out here, means that the input is being squared rather than the output being squared. I go one extra step and include an extra set of parentheses here. Usually when I write up problems, which is not indicated in the book, to allow people to definitely know that I am squaring the input to the function and not the output of the function itself. But knowing that, because I just told you, and it is a convention, then we can proceed accordingly. So, there's one set, and the input is being squared. So, we know what the derivative of sine of something is, right? So, let's treat this whole thing on the inside as an inner function, right? And we just take the derivative with respect to this whole thing in the middle as a function, right? The other thing that we might want to do is actually go one more step and simplify this a little bit more. Instead of having to do two applications of the chain rule, if we just rewrite this as sine of pi squared x squared instead, and we'll still box this guy here. Alright. Some people said that it was easier to think of it this way. So that's the way that we're going to think of it. So we take the derivative of sine with respect to our red box. So the derivative of this will be derivative of sine is cosine. That is something that you are, sorry, so I'm going to have to write y prime here. Derivative of sine is cosine. That should be just something that you know off the top of your head. And we bring down everything that is inside of the red box. Right, so that maintains. And then you multiply, because the chain rule says that you could take the derivative as if everything in our red box was the variable that we are taking the derivative with respect to. But then you have to find what the derivative with respect to x is of everything that you put down in your red box and multiply it. So the derivative of this, well, some people get thrown off by the fact that pi is a symbol, right? And we're taking the derivative of this symbol. But really, I mean, pi is just a number, a very cool number that has special magical properties. But it's still just a number nonetheless. It's approximately 3, right? So 3 squared is 9. So this is kind of like the problem 9x squared, right? So what you would do is you would take the derivative of 9x squared, you would bring down the 2, multiply it to the 9, and you would get 18x as the answer, right? But we have to leave the pi squared because we don't want to, it's approximately 3, but it's not 3 exactly, right? It's 3.1415, etc., etc., etc. So we just leave it as a symbol, right? And we bring down the 2, we multiply it to the pi squared, and then we multiply it to the derivative of that, so we get just x here, right? So this is the derivative of what's inside of the red box. So, simplifying a little bit, let's bring some of these constants out front, and usually we write these lower order factors of x, and we bring them out front too, so we get 2 pi squared x cosine of pi squared x squared. There's a very practical reason that we bring these x's to the front, so that you don't get confused as to what's going inside the function and what is outside of the function. Okay, so that's number 49. Number 51, we can use the product rule to figure these out, but we don't know what the derivative of sine of 2x is. We know what the derivative of sine is. We know what the derivative of cosine is. So let's draw some red boxes. And as it turns out, I don't need to use two different colors, right? One for this 2x and one for what's going into the cosine of 2x, because they're both the same, right? So these are both the same quantity here. So I can take the derivative of either one of these two things and then just by the chain rule multiply it by the derivative of what's inside of the red box with respect to x. So by the product rule, I hold one of these two guys constant, so I'll hold sine of 2x constant and take the derivative of the other factor. So the derivative of cosine of the red box is just going to be negative sine of whatever's inside the red box, so that's 2x. And here I brought that negative out to the front, right? Just because I am, that's just a factor and I don't want to include grouping symbols all there. And then I multiply by the derivative of 2x, which is just 2. And then I add to this, well, last time I held sine of 2x constant, so this time I'll hold cosine of 2x constant. And then I multiply by the derivative of sine of 2x, which is just cosine of 2x, times the derivative of 2x, which is just 2. So I have a 2 that's in common between the two of these guys, right? I have a 2. And then I have a cosine of 2x quantity squared minus a sine squared of 2x. Right? So I can actually use here the power reducing formulas, which is, let's see, cosine squared of u is equal to 1/2 times the quantity of 1 plus cosine of 2u, and then sine squared of u is equal to 1/2, let's see, what was it, minus cosine of 2u. Right? So, the u in our case is 2x, right? So, then 2u would be 4x. So, h of h prime, this should be h prime, derivative with respect to x. Then h prime of x will be equal to, here I have a 2. This guy gets replaced with this. So this is 1. I notice that I have a 1/2 and a 1/2. I'll have them in both terms. I'll just write it out anyway. Be explicit as I can. So this is 1 plus cosine of 4x minus 1/2 times 1 minus cosine of 4x. Running out of room there. Okay, I notice that I have a factor of 1/2 in both of these two terms. I'll factor it out, and notice that it will cancel with that too. So that kind of gets rid of that, so that's nice. So I am left with 1 plus cosine of 4x minus, distribute this negative to both of these, minus 1 plus cosine of 4x. This one cancels out with that one. I have 2 of these cosine of 4x's, so that's 2 times the cosine of 4x. And that is what my derivative with respect to x is equal to. Okay, and that's what you should get in the back of the book. So that was 49 and 51 from section 2.4.